The Pilkington Company is established in 1826, so in England. Now we have a factory in Russia, near Moscow, from 2006, which produces glass and high-performance coated glass, which is brand name is Suncool. And this glass has wide variety of parameters set for any building. And the thing is that our factory is very export oriented. So we export to around 40 countries around the world and have an architectural projects there, from Mexico and Honduras to New Zealand, and of course to Southeast Asia also. My name is Slava. I am head of a technical department for export projects for our Russian factory. And let's go into the topic. Today's topic is a visualization, but in my opinion, visualization is good when it brings you very close to the reality on the facades. And I will be talking about visual distortions, meaning distortions on the facade. Because when you're pretty much everyone, including architects, they are doing modeling of the facades. On the model, they all looks nice, good, and perfectly flat. The glass is perfectly flat. But when it comes to reality, and the building is ready-made and done, there are a lot of distortions which you can see in many cases. Of course, most of them because of physics. Physics cannot be avoided, you know, we're living in the physical world. And today we will be talking about how to estimate the correct IG unit composition to minimize these distortions. First of all, usually for any big building, the calculation of IG unit is made in terms of its performance, of course, and because in terms of its behavior on the facade. The static calculation usually gives you two results. First one is maximum stress on the glass, which means if the glass will be broken under the loads or not. So under the wind, under the temperature, this thing. And the second thing is glass bending. So those two parameters you get from usual calculations. But the very important thing is how to correctly see and interpret the results of the calculation. We take into account several load factors. Wind load, of course, because if you're building a tall building, the wind will be very high. Second one, and very important, are the climate loads, because IG unit inside has some air or argon, meaning gas. And it is hermetically sealed on the perimeter. So when the IG unit is installed, when it gets heated up, the gas expands and the glass bends, creating distortions on the facade, which many don't like really. Of course, apart from these two most important ones, wind and climate, we take into account snow and other special loads. Snow load is case for Russia, but not the Southeast Asia, except for mountains here. So some examples of our weather is included on the slide. Okay, jokes aside. Glass is calculated under extreme load conditions, meaning the wind, which can happen once per 50 years, so twice a century. This is very important because the most important function of the facade is to withstand maximum load combination and do not break. Nobody likes when the facade pieces are falling apart on the people's head. But if we want to bring it closer to reality, meaning visual, what we see every day, nobody will look on the facade when it's a hurricane raging. And the thing is that if we look to the bending of an outer glass, because the outermost glass gives us the impression of the facade. And when we take maximum loads and usual loads, the results are extremely different. You can see it on the slide. So here, This is glass deflection, and the external glass is deflecting in one way under peak loads and in completely different way under the climate loads. So for comparison, there are two IG units combinations which are calculated rather differently in this case. And the goal today is to estimate how the glass will look like in real life, not under peak loads. So to sum up the first part, regular calculations are done under maximum loads, under worst happening conditions, and they give you completely different results. To get back one slide, the most important thing in every calculation is glass, in every peak load calculation is glass stress, meaning we are estimating glass breakage. And the glass breakage and the conditions under which the glass breakage happening are not valid for our estimation. So how do we minimize these optical distortions and how do we predict them? We need to determine the correct load condition. So, and here is a good example of the facade with the lens effect. If you see on the top of the picture, that is how the visualization of the facade with the via digital instruments looks like, this part. It doesn't reflect anything and the glass is absolutely flat. But what we're trying to estimate in advance is this part. So how many distortions you will get. In order to get the correct result, you need to consider the lens effect first and foremost. And in order to understand what do we do, let's see which kind of loads can be applied. Peak loads, so maximum wind, usually has very short duration. Special loads like human impact also have very short duration. So for in normal life, we don't expect very big wind bursts. And here comes climatic part and snow part. But snow part, again, for those countries that are very snowy. Out of that, we can gather that climatic loads are the most important thing for us. And under these loads, the visual performance of the facade should be estimated. So these loads are long time, and we are good with that. So climatic loads here should be throw away the wind. In fact, no, because the wind is, not the strong wind is regularly present, but we should take the wind which is happening every day under everyday conditions. And there we can go to the calculation process. The climate load are most important, as we understand before. So, but what is the climate in terms of IG unit? For IG unit, the temperature which is inside the IG unit does matter. The temperature of the gas between the glass. By the way, if you install single laminated glazing without gas, this thing is absolutely mostly unaffected by climatic loads, which is good for lamination, but very bad for energy efficiency of the building in terms of solar control and U value. In order to understand how to calculate the temperature inside the IG unit, we need to calculate its parameters, take into account climate outside, including temperature inside building and temperature of the outside air. We need to take in account solar radiation, sky temperature, and average wind speed, meaning if the glass is overheated, the wind is good for you because it takes away the heat faster. Combining all of these, we can calculate the temperature of the gas inside the IG unit. Of course, the more solar absorption it has, the bigger the temperature will be and the bigger the deflection will be. Also, it goes for the spacer. the wider the spacer, the more gas is inside of it. And the more gas, the more the gas expansion. So we estimated the temperature. Now it's time for us to estimate the rest. First one is the pressure, meaning atmospheric pressure. This is mostly happening for the buildings, high-rise buildings, skyscrapers. But it's also very important to take into account if your building is located quite far away, and most importantly on the different sea level than your building. So building and production. Difference does matter. In some cases, if you are producing your IG units on the sea level and then transporting them high up into the mountains, you can install special valves to dump the pressure out. But these are nuances, but they can also be taken, considered in the calculation. So temperature, pressure, and height difference, plus the wind. For wind, we can use normal climatic data from our internet, from the websites with dealing with weather, to see average wind conditions. Usually the conditions are present like at a wind speed, but wind speed can quickly be transformed to pressure using the simple equation. And mind you, we're not taking peak wind speed maximum. We are taking regular wind speed, which is happening every day. Our goal again, to calculate everyday situation. Combine all of this and go to the results. So I will sum up really all of the points which I've done. So deflection of an outside glass is the key. All of the glass are deflecting, but for us, it's very important. Outside glass is very important. Furthermore, if you're using high performance glass with coating, it's usually a little bit more reflective than the normal one, giving you another reason to look specifically for outer glass. Now, the really important, so we combined all of the things together and get the results. Glass deflection. How to evaluate it? Because IG units, the size of an IG units can vary wildly. You can have 1 meter per 1 meter, and you can have 3 meter per 6 meter, for example. The deflections will be different. So the key here is to evaluate the millimeter of bending per 1 meter of shortest side of glass of an IG unit. And in this, you can compare big IG unit to a small one. From our experience, 2 millimeters per meter of bending under normal conditions is usually considered acceptable. And of course, the main thing which is affecting is the thickness of the outer glass. That is the thing which usually not considered on American market, surprisingly for me, because those guys like thinner glass, and it can bend like a sail, but outside, from an outside, it will not be looking good. Of course, the reality gives us much more to think about. There are several other factors. First one is the most important one is the glass reflection. The more reflective is the glass, the more visible this optical distortion, the glass bending will be. So the more reflective the glass, the bigger the requirements for a proper IG unit design in advance. I understand, and the same goes for darker glass, because if the glass is dark, it lets much less light inside of the building. So the lighting difference outside of the building and inside is much bigger. And that gives us visual reflection. Even if the reflection number is the same, the visual reflection is bigger. So the darker glass the more reflective it is, the more you need, the more attention you need to pay to the proper IG unit design. And these requirements of 2 mm per meter can be lowered. And it all can be estimated in advance. Please bear in mind that I'm not saying that the calculations which are done now are wrong. No. The calculation under maximum loads are absolutely necessary for you to give your building safety. But in addition to this, you can estimate the visual look on the facade by conducting a special additional calculation of the climate under climate loads, under everyday loads, and see and compare different combinations of IG units depending on what you're planning to do in a building. For example, this is, sorry for a lot of numbers, but I will highlight you the key numbers. IG units are calculated under peak loads on the top here, and you see the bending. These are huge. Does that mean that, does these numbers mean anything to us? No. Under peak load combination, we should be looking not for glass bending, but we should be looking for the stress on the glass. Will the glass hold? If it does, we have no problem. Let us continue, go on and make a calculation of the climate loads. And you see the numbers are vastly different. And here we can compare IG unit compositions in terms of bending. And in here, all of the, mind you, all of the size is the same. And here we see that if we install thicker glass as an outer pane, then the bending will be much lower, and your facade will be much more straight, uniform, and good looking, basically, because that is the goal of this visual estimation. Now, we are in Russia, we are performing these calculations for a long time already. And usually we provide customer with both of them. For example, so for him to see, will the IG unit hold, first thing, and how to compare different IG unit combinations. This is the key for understanding the behavior of the facade. Of course, it can be also visualized, and the previous speaker has a very good presentation about beam possibilities. It can be all be visualized with beam and visually estimated in advance. Some nuances to this, because different IG units react differently on the loads. Here, you see that the facade is made of exactly the same IG units of exactly the same size. But here we have transparent zone, and in between we have non-transparent zone. Again, combination and size of the unit, IG unit are the same, but visually the non-transparent part is looking much worse. That is simple because usually it has IG unit, the IG unit for a non-transparent part has standard glass outside and painted glass in the inside. That means in the summer it will heat up a lot, and on the winter it will be much colder. Oh, okay, if you have a climate difference, because I once looked for a climate of Singapore and the temperature was for the whole year was like this, straight. A little bit of envy from my side, but okay. So back to the point. Different facade parts should be evaluated separately if you want, and the IG units for a different building part should be designed separately. So the composition could be different for a non-transparent part of the building, even if the size is the same. So basically, this is it from my side. The point of today's topic was that please be smart in your approach. to the building, because visually on the architect's render, it always looks beautiful. But when you come to the details and you will come to the realization of your building, there could be some problems. And it is far better to use the expertise and to estimate the bending and the distortions well in advance to get the correct IG unit composition for you. A little advertisement. We are Pilkington, Russia. We can do that. 20 years of experience, I might say that, not only in Russian climate, but all the others. And you can address us in this case. Thanks a lot for listening. I hope that it was helpful to you and you will learn something new. Thanks again to Perafi and GlassTech Asia for providing me the possibility.
So is it really necessary for climate like Southeast Asia to use a DG glass for facade?
It depends. Thank you for thanks for the question. Right, it depends, but mostly I would say yes. Okay, everybody knows what is happening with the gas prices and oil prices right now, and electricity. And the heating and for Southeast Asia, cooling of the building is consumes a lot of energy. Of course, if you're building a residential building, so the people attending for themselves, but if the building is commercial and have central cooling system, centralized, then IG units can provide you incredible savings, and in terms of not only of the price of cooling itself, but also the installation power of the cooling system could be much reduced. So as the price of the cooling system. So if anybody is building a building for themselves, yes, he's investing something into IG units instead of simple LAMI or tempered glass. But he can gain it from the equipment, the drop of the equipment price, and for sure, he will gain it from the reduction of the costs. Okay, that's not the point of my today's presentation, but it also can be digitally estimated. How much can he save? What is the buyback period?
Returns.
Yes, thank you. What is the returns period of this? It's all can be estimated in advance, and you are free to address and compare.
Great,
but
great.
The answer to the question, in my opinion, yes. Not because because we are the producers of the coated glass, but because of the reasons which I explained.
Yes, I totally agree with you. Having a high performance double glazed unit will help us to achieve a better energy efficient building.